again, with our leading coefficient test, we're going to utilize that along with our zeros to sketch the graph. Hopefully this looks familiar, folks. This is a slide from last class. So, the graphs of polynomials, we say, are continuous. Meaning what?
No holes, breaks.
So, as long as we don't take that pencil off the paper, we have ourselves a continuous function. And how do we draw those functions?
With smooth drawing curves.
Absolutely. As Chris said, no sharp turns. Again, we had this from yesterday, but a nice segue into what we're doing today. So when you do draw these graphs, plotting the points and then connecting the dots, do not do anything like that might represent some stock market or something like that, but that does not represent a polynomial function. Okay? So nice smooth curves. So step by step, I'm sketching the graph of a polynomial. One of the tests we learned about coming up with the end behavior, what the graph looks like on the right side and on the left side. What test was that? Absolutely. So our leading coefficient test determines rising, falling on the left side, on the right side. After that, we can go ahead and find those zeros. The zeros will help determine the points. Remember, the zeros are the same thing as my what on the graph? It's intercepts. So boom, I have 2 points on my graph, 3 points, how many ever we're dealing with. And then we want to plot a few additional points. Where we use the zeros to determine the test interval. And I will explain all that in a second. So what he's talking. But we use these zeros, I'll show you it right after this, which we use the zeros to obtain these test intervals, which tell us a lot about the graphs. Once I have all this information, the only thing left to do is sketch the graph. So this third one, plot a few additional points using the zeros to determine the test interval. If we take a look at our polynomial function, what is its end behavior first thing? On the left it is falling, on the right it is rising. Where are my zeros? Oh. There are my zeros, right? What do I notice if I break up my graph interval-wise by the zeros? So from negative infinity to this point, from this point here, and then from here to here, and likewise from here to positive infinity. If I break up my graph with those zeros, what do I notice about my function? Well, from negative infinity up to the zero, my graph is what? Positive or negative? On this interval. On this interval? And on this interval. In order for me to go from positive to negative, I have to go through a zero. So if I use my zeros and come up with these intervals, I just have to choose one test point, any point there, and if it comes up positive, I know I'm above the x-axis. If it comes up negative, I know I'm below the x-axis. So that's why these additional points help out, and again, these are my test intervals to determine Okay, I know the entire interval is down below, and we go from there. So, here we want to sketch the graph of f of x equals 2x cubed minus 6x squared. First things first, read. Can you help us out with that leading coefficient test? What is the end behavior? And it's odd, and my leading coefficient is positive. So what's going on with the left and what's going on with the right?
The left is following right and right.
How did you come up with that?
Because it's the same as cube.
Absolutely. Thinking back at the odd, percent, thinking about any odd power, 3, 5, 7, 9. Hopefully we don't have to graph anything to the negative 3, or negative 7, 3. But any odd polynomial, right, where it's positive, which then we want to think of our x cubed, which is falling and rising. If it was negative, it would be what? Reversed. If it's an even one, x squared, x to the 4th, x to the 6th, it's a positive coefficient, what would that look like? Absolutely, so both sides will be rising. Negative. So that's all we're doing, comparing it to that parent function, right? X squared and x cubed for that leading coefficient test. So my zeros. Kyle, what do I want to do?
Find bring set equals 0.
All right, let's set equal to 0. That one? Find that GCF, absolutely. 2x what? Alex, show my zeros.
0 with a multiplicity of 2 and 3.
Multiplicity of 2 and 3. Absolutely. Here we have x squared. Right? Came up with the zeros by setting each one of these equal to 0, right? So x squared equals 0. So that's the same thing as saying x times x, or x equals 0 and x equals 0. There's 2 zeros. Whereas my x minus 3 equals 0, there's just that one x. So what does that mean? Ashley. Having the even multiplicity for 0 and the odd multiplicity for 3. One of them means it's just touching, and the other means it's crossing through. And a 50-50 chance. For what, both? Think of f of x equals x squared. That's an even one, right? 2 zeros. Does that go through your x-axis, or does it just touch it?
So if we have x, just because it's even, it means the same thing.
Absolutely. If I had x to the 10th, this was 2x to the 10th equals 0. I had 10 zeros. I had an even amount. So it is not going to cross the x-axis. It's just going to touch it, just like our x squared. Absolutely. So here, since we have those zeros of 0 and 3, we can use, again, create those test intervals from negative infinity to positive infinity. So negative infinity to my first 0, and then in between my zeros, and then from 3 to positive infinity. Again, this is going to help us as far as determining on these intervals, is my graph negative or is my graph positive? So we just come up with any values of x inside those intervals. And Chris will help us with that. So in between negative infinity and 0. Okay. 0 to 3.
2.
Okay. I would have chosen 1, but that's fine. 3 to infinity.
4.
Hey, at least you didn't choose pi or something like that.
So here we're just like Picking a random point to put up.
You can choose any point you want. If you wanted to, you
As long
can
as
say
it's in-
2.796.
So as long as it's in between whatever.
Absolutely. It's just like, right, it's just finding a test point. Again, once I determine when I have that -1, it comes out to be a positive value. I know that every single one of these is above the x-axis. So yes, as long as you're not choosing the endpoints, zeros at 0 and 3, just choose any point you want. So how do we find that f of x? What do we do? So I have that -1.
You substitute it into your original equation.
Absolutely, substitute into the original equation. So that -1, what do we get?
-2 minus 26.
Absolutely. Not only do I have a point that's on my graph, but now I know that all the points between -infinity and 0 are where? Below the x-axis, absolutely. Now I have the 2. I need to make life a little bit challenging for Gloria. But now here, if you take a look at this, if we're going to use 2, in particular, if we're using it with this, 2x cubed minus 6x squared, let's say you chose, well, we're going to do 4. 4 is going to be a little bit challenging, won't it? However, isn't this the same thing? We just factored it out. So here, when I'm evaluating my x equals 2, it's the same thing as if I want to use my factored form. Two minus 3 is -1. So we actually just come up with -8. I could have also used the original equation, right? Just 2x cubed. So 2 times 2 cubed minus 6 times 2 cubed squared. Sometimes that does get a little bit, especially when you have the higher powers or the larger numbers, it makes it a little bit complicated. But if you use your factored form, sometimes it makes it easier. Sometimes, not always. So, value of 4 for x. Dollars. Absolutely. Whether you, again, use the original equation, or whether you decide to use it factored. So now what? I know my end behavior. I know my zeros. I know the intervals on where I'm positive and negative. What's left to do? Absolutely. So I'm at 0, 3 for my zeros. My end behavior, we know that we are decreasing on the left or falling on the left and rising on the right. I have some additional points, right? I have a -1, -8. I have a +2, -8. And we also have 4, 32, way on up there. So what do we do? We just draw it. Yes, gets the graph. So we're done. Ask the questions. There's a question here. Somebody's going to ask. I've got time.
Why isn't the 4 on the point?
How come I went past that point instead of turning on?
Did you have that smooth?
I actually went beneath it.
You didn't solve for a minimum.
Absolutely. As Sean said, when we have all these points here, all this stuff is great. It helps us sketch, not draw it, but sketch the graph. You will not be able to find those relative extrema, relative maximum, relative minimum, without using calculus. You actually have to use the derivatives, which we don't go over in this class. We'll find that out next year for those of you taking calculus. You have to find the derivative to go ahead and find that actual point, but use common sense, right? It's going to be a nice smooth curve, right? So it's pretty much going to be parabolic in shape. So between 0 and 3, I'd expect at 1.5 to be my relative minimum, right? So that's why, okay, let's try something like that. Any questions on this?
So technically, on the quiz or something, it doesn't have to.
We're just sketching the graph. So it's not going to be accurate, definitely. A lot of you will have different relative maximums and minimums, unless you happen to know derivatives. Okay? So that's what's nice about sketching instead of graphing, right? So here, we want to sketch the graph. What's that? This is a fun one too. Sketch the graph of f of x equals negative 1/4 x to the 4. Daddy. Sean, can you tell us about the end behavior through the leading coefficient test?
Oh, I can't read it.
It is negative 1/4 x to the 4.
Okay, well, it's less than 1 and it's even, so it's going to be falling.
Absolutely. Falling and falling, comparing it to what? F of x equals a negative x squared. Squaring function with a negative, Sean said, it's falling on both the left and the right. What do I want to do about those zeros? All right. So starting off with do we have it set equal to 0? Dominic, what should we do now? Let's go to the next problem. Do we like fractions? What can we do? Absolutely. Multiply by 4. Or in this case, we can actually multiply it by not just 4, but by negative 4. 2 won't do anything to those 4s, guys. Things like my grandma, just guessing around and throwing some numbers here. But no. 4, as Dominic said, will get rid of that, all the denominators, but that negative, since we already had that negative in the beginning, if I multiply everything by a negative 4, I'm going to have what?
Wait.
Yes?
Won't that change the zeros?
What's on the right side? As long as it will not affect the zeros, but it will affect something else, which you can bring back to in just a second.
Okay.
So, what do I do now? Giving me? See, because I did negative 4 to both sides, my one side is 0. So even if I had that coefficient, negative 1/4 to begin with, ultimately I would be throwing it to the other side, which is 0 anyway, and just disappear. So it's a negative 4 times a positive 3/2, negative 6. So now what do I do? See? Okay. Factor out what?
X squared.
Now we have a very complicated trinomial where we need the quadratic formula, right?
Yes, exactly. No.
Right?
Yes.
So, Caden, what are my zeros?
It's 0, and 1, 2, and 3, and 1,
Right?
yes.
That's what it is. X squared, so this gives me a 0 and a 0. And here I have 2 of these, giving me a 3 and 3. So both of them having that multiplicity of 2. What does that mean, Nicole?
It's touching.
Absolutely. That they touch the x-axis, never crossing. And this is all going to be either all completely above the x-axis or completely below the x-axis, never crossing over. I'm sorry?
So only have to do one test.
You still want to find some additional points. So, with the test interval, again, split up by the zeros. Looks familiar. And we can either use the same numbers that Chris gave us or something different, and it's all up to Harrison.
Negative 1. 1.
Absolutely. I didn't want to do something like 0.6 or something. So here, once again, we just want to go ahead and evaluate these points, sticking it into original format or factored. Move on. So, here's the thing. This is something that Caden talked about. Here I have my negative x. I don't have a negative x. Here I have a negative 1 for x. Since I want to put it into this, can I use this? Are these two the same?
No. Because this one goes up.
Because over here, what's this one missing? It's missing that negative 1/4. Yes, what did I do? We multiplied left and right side by that negative 4. I altered that equation because if I actually have something on that right side, that should have also been multiplied by negative 4. So we actually have to, here, if I just pull out, say, that negative 1/4, like we did over here, where actually we pulled out we multiplied by negative 4. Same thing as pulling out a negative 1/4, leaving behind the factored form of if I pull out the negative 1/4, instead of multiplying both sides by negative 4, if I pull out a negative 1/4, I have my x to the 4th, right, minus 6x squared plus 9x squared.
Is it still going down?
Yeah, the end behavior is still the same. Did everyone see what I did? Why we can't use this? Because when we found the zeros, it was perfectly fine to multiply both sides by that negative 4, right? Because my right side was 0. But over here, my right side is not. It is actually a number. So I have to take that into consideration. So we may have to make sure that we keep that negative 1/4 there. So now when I evaluate at negative 1, we set x equals negative 1. And here we're going to get what? Negative 1. So negative 1 minus 3 is negative 4 squared. So positive 16 times that negative 4. Or negative 1/4. Negative 4. Evaluating it at positive 1. What do we get? You don't have to try doing this in your head, folks. All right, positive 1, so 1 minus 3, negative 2, squared is 4. That's just 1. 4 times negative 1/4, and negative 1. And then a positive 4. Sorry? Yes, no. Now let's plot this. So we have our zeros at 0 and 3. End behavior, we know. Sean told us falling on the left and on the right. And I also have some additional points at negative 1 and negative 4. 1, negative 1, and 4, negative 4. What does that look like? With me then? Sorry. We wind up with, again, I'm not stopping at 1, negative 1. That's not my relative minimum. But if I take a look between 0 and 3, probably at about 1.5, I want to have that relative minimum.
Can we guess that y value, or do we just like how far it goes down?
You're going to go here, here, here. Again, the only way you're going to know that, I mean, if you want to, you can say, okay, 1.5. I'm going to choose 1.5 and evaluate that. Have some fun, especially if you don't have a calculator. Don't expect it. Yes.
When determined if it crosses or touches? Is it like if it's
How do we know if it crosses or touches? Even or odd multiplicity. Even multiplicity touches. Odd multiplicity. One more fun one?
No.
Okay. And 2 more.
Dang it.
You guys didn't want one, so 2, 3. So here we're going to sketch the graph. That's all everybody? They're still over. Okay. So we're going to sketch the graph f of x equals 3x to the 4th minus 4x cubed. What is my end behavior from the leading coefficient test? What's that? Absolutely. It's an even, right? So I'm looking at f of x equals x squared. Positive, just like our parabola, right? Zeros, once again, set it equal to 0. Yeah, what?
Or x to
So what are the zeros?
0 and plus 3. And then 4/3.
Absolutely. Because here I have x cubed, right, equals 0. So there's 3 of them there, right? 3x minus 4 equals 0. Solving for x gives me that x equals 4/3, but only one of them. So both of these, what's happening? So now for my test intervals. So we won't use Chris again for these. We're not going to go past. Some nice simple ones, right? So evaluating that -1, whether we decide to use the original or the factored form, we did not alter that factored form, right? We just factored it out. So either way, when we use -1, what do we come up with?
7.
+1? -2? And for R2? I don't know. Asking someone to take Alex's answer and saying, yeah, it's got to be right. This is right. And then just sketch it. Absolutely. So our end behavior, again, we know increasing on, rising on the left and right by zeros. There. 3 extra points. -1, 7. 1, -1. And 2, 16. Okay. Yeah, that didn't look too well. Right. But over here, you'll notice there is a little squiggle. When you have that multiplicity of 3, it is crossing the x-axis, but indicating that there is a multiplicity of 3, you will have just a little squiggle, a little wiggle. I'm not going to harp on that, but you will see that on your in your book and on the solutions and stuff. The important thing, knowing the end behavior, does it cross the x-axis? Does it touch the x-axis? You guys will not know where the relative maximum min is, but a good idea, A, is right on over here.
So we can't just draw like a parabola.
No, if you draw a parabola, that's equal. You guys want to practice some?
Yeah, we do.
Is this
On
the
chapter
one?
paper.